already pressed the record button. Okay, so today we will start with chapter 2, Fourier series part 1. Okay, this is part 1. So, okay, here is actually, you can see we have a graph like 3-dimensional. Okay, you have the time domain, you have frequency domain, you have amplitude, frequency, and time. Okay, this is the axis value. Okay, this is just the same case as the, you know, maybe you guys familiar with story where there is a blind, okay, a group of blind people trying to visualize how an elephant look like. Do you guys know this story? So some touch at the ear, some touch at the task, some touch at the body. Okay, different interpretation, but it is the same. It is the same elephant. So similar with this case. Okay, similar with this case. Okay, similar with this case, you see, this is from time domain. If you see from time domain, you have a signal like this, analog signal, analog continuous signal. Maybe this one, let's say this one is frequency 10 hertz. You have this. Second, you have like this. You have 20 hertz. It is more. You know, more compressed. Okay, you have more complete cycle. Maybe this one is 20 hertz. Okay, and then the next one is 30 hertz. Okay, but this is the time domain when you look from this side. However, if you look from the other side, the frequency domain, is another way of representing our graph. Okay, our signals. So this one is 10 hertz, where you can see only one spike here, and this one is 20 hertz, and this one is 30 hertz. It's just the different way of viewing. Okay, different way of viewing. So this is the outline of today's lecture. Okay, sinusoidal signal, Fourier series, effect of Fourier series characteristic. So this is UTM sharing from Facebook. From UTM Facebook, they shared the recent photo. I'm not sure you guys aware or not. I take it and put it inside. Okay, so it's quite beautiful, UTM. Okay, so I was UTM student for degree, master, PhD. So okay, I think you will go to like UTM. Okay, so sinusoid signals. Okay, sinusoid signal expression is a time domain graph. Okay, it's in a time domain graph. And then we have also frequency domain spectrum. Okay, this we have spectrum. Later we will touch on that. And then we have exponential phasor representation. We have complex exponential representation. When we touch about exponent, we will have this like E for exponent. And then we have here is the periodic signal. Okay. Please don't ask me in WhatsApp during lecture. I think you know how disturbing you are to the rest of the lecture student. Okay, for me and to your friend. Okay, don't disturb using WhatsApp. Okay, we have Google Chat here. You guys can ask me in Google Chat. Okay, but don't ask something not related to lecture. Now we are having lecture asking about quiz. The quiz is already mentioned in e-learning. When is it? So I don't know, clearly when students ask this, they didn't look at e-learning. So it's a bit sad. It's like no use I put e-learning if students don't bother to see. Okay. So you see here is signal expression. Okay, sinusoidal signal is a common type of signal used in various systems. Okay. Consider a time varying voltage signals because you see Vt A naught cos omega naught t plus A plus theta 0. Okay, later on in subsequent lecture, okay, you cannot write simply A, small letter A not. You cannot write simply because it have meaning. Later on, you will learn that there is capital A not, small a not, small a with n subscript, and small b with subscript n. So make sure don't write. Some people they like to write. They say this a not. They like to, instead of write capital, they will write small a not. Just preference, okay? So avoid this preference because this have meaning, okay? So where A is amplitude of the sinusoids, okay, amplitude, and then we have omega naught, where is angular frequency, okay, this is omega naught, and then theta naught is your phase shift, okay, phase shift. Then we have here, for example, AT equals to A naught sine, okay, you see here is sine omega naught T, then A naught sine 2 pi F naught T. So if we were to consider to convert sine to cos, okay, to convert sine to cos, we actually will have negative pi over 2, okay, minus pi over 2. So can be written as sine omega naught T plus theta naught, but with a difference of theta pi over 2. I think you guys are familiar, you guys know this already because you have a sine cosine graph like this, and you have sine graph something like this, okay? So you see there is a difference, okay? There is different what? Lambda theta pi over 2. There is different of 90 degree, okay? So that's why when we want to convert from cos to sine, sine to cos, you need to consider this case, okay? We need to consider pi over 2, okay? Pi over 2 is 180 over 2 is equals to 90. Sinusoid signal can be presented in time domain and frequency domain. So depends, the question asks you time domain or frequency domain, okay? But it can be presented in either of them, okay? Now we go to this time domain signal. Sinusoid signal can be sketched in time domain graph. Okay, so we consider a time varying voltage signal. Okay, consider a time varying voltage signal. Time varying means it's differ with time. Okay, so you see T is 1 over F naught over 2 pi omega naught. So I think this one is pretty straightforward and you guys understand. And A naught, and you have this time domain signal. Okay, this is not a good graph. Why? Because they don't label the x-axis and y-axis. Make sure you always label. I always mention this in class, remind. Okay, because it's important. For me, I will cut the mark if you guys don't. I think other lecture will also do the same, because if you don't mark, if you don't label this axis can be anything, and it is not complete. Okay. Next, frequency domain signal. We see spectrum. Okay, spectrum. Spectrum is actually to describe our frequency domain signal. Each sinusoidal has a frequency f, amplitude a, you see capital A, and phase theta. Amplitude and phase can be plotted with frequency to produce spectrum signals. Okay, amplitude and phase can be plotted with frequency to produce spectrum signal. You can see here A1 cos 2 pi f1 t plus omega theta n. You see this is 2 pi f1. So if we convert to omega, is actually omega 1. The same goes here, 2 pi f2. If we to convert, it is actually omega 2. Okay. So here we consider when we want to do our frequency domain signal, so we will have two kinds of representation. Okay, we have amplitude spectrum and we have phase spectrum. Okay, so amplitude is for us to plot our amplitude, and phase spectrum, yes, for the phase. Okay, so omega 1 is 2 pi f1 we put here, and with amplitude of a1, and omega 2 here later will be amplitude of A2. But please bear in mind, question can be tricky, maybe, okay, maybe omega 2 is actually before omega 1, okay? So you need to, you just need to be aware, okay, of this subscript and superscript, okay? And then later on, theta 1, here you have at omega 1, you have theta 1, and omega 2, you have theta 2. Why you have down? Because it is negative here. Next, okay, here, plot the example, plot the amplitude spectrum and phase spectrum for signal below. So you have here is A cos omega naught t minus B cos 2 omega naught t plus C sin 3 omega naught t. You see, we have 2 in cos, 2 in sin. So logically, I mean, you will try to solve where you try to have only one cos, okay, or only one sin, for example. So here, seems that sin is the minority, so you need to, okay, you can convert it to cos by following this hint, okay. Negative cos theta is equals to cos theta plus pi, and if sine to be converted with cos is sine theta is actually cos minus pi over 2, okay, with 90-degree phase shift, okay. So you can see here, C sine 3 omega naught t, we introduce negative pi over 2, okay, the phase difference, okay, the phase difference. Okay, then you plot the amplitude spectrum and phase spectrum. So first you will have omega naught, second angular frequency omega 2 omega naught, and third angular frequency is 3 omega naught, okay. And the same for the phase spectrum. Then you just need to plot the amplitude A, B, and C. So it is continuous, okay, continuous from the arrow, continuous from the horizontal axis until to the value. Let's say this one is 2, this one 2, this one B, at least they say this is 1, so this one should be 1, and they say this is 3, they should be 3, okay. Okay. Next is a phase spectrum. You can see here is A cos omega naught t at angular frequency of omega naught. there is no phase shift, so this one is 0. At 2 omega naught, you have phase shift of pi, and then at 3 omega naught, you have phase shift of negative pi over 2. Okay, so there is difference. Okay, between amplitude. Okay, you can see that you need to represent your answer in amplitude and phase spectrum. Okay, next, consider this condition. Okay, now let's say you have V and Vt equals to an cos omega naught omega n plus t plus bn sine omega n t. Now you see, right? Now we have, instead of we have capital A, now we have small capital A, and instead of not we have n. So it is different. Eh? They are not the same. That's why later on, please be be careful when you write your answer. Okay, omega n plus bn sine omega n. If you see, they both come from the same angular frequency, which is omega n. If it's different, then if this different, the equation should be like omega m. This is omega n. Okay, but using the same n means it is the same. Okay, because it's using the same nomenclature, the same labeling. Okay, so then actually, if this is to combine into one cos, it can be an cos omega nt plus theta n. And you consider this equation. Actually, an, capital An is actually the square root of an squared plus bn squared. Square root of this plus square root of this, square root of square of both of this term. And then theta n, the phase shift, is actually the inverse tangent. And you see here, there is negative. Inverse tangent negative of bn over an. Okay. Now we are to plot our spectrum. Okay. An is actually omega n at this frequency omega n with amplitude of an here. Okay. So it's here. The phase spectrum similarly also phase spectrum. Omega n is the frequency. However, then instead of amplitude, because it's phase graph, phase, so this one should be theta n. Okay. This one should be theta n. Okay, because it's phase spectrum. Okay, so this one should be your phase. Okay, next, phasor representation. Okay, phasor representation. Sinusoidal can be shown as x-axis or y-axis projection by an anti-clockwise rotational phasor. Okay, Chintong, please remind me at 11:50 to have rest at 11:55. around 5 minutes, 11:55 until 12. Okay, please remind me at 11:50. Okay, sinusoidal can be shown. Not sure Chintong listen to. Okay, noted. Okay, sinusoidal signal can be shown as x-axis or y-axis projection. Okay, sinusoidal signal can be shown as x-axis and y-axis projection. Okay, by an anti-clockwise rotational phasor. Okay, so anti-clockwise, no, not clockwise. Okay, if it's clockwise, you will have negative. Okay, so here Vt A naught cos omega t plus theta 0 or theta naught, or Vt, if you want to, in terms of phasor representation, it would be like this: A naught angular and omega naught t theta 0. They say this is 45, so this is 45, so this one is accordingly. Okay. So now we go to complex exponential representation. When we refer to exponents, mean your answer will be in exponent, you will have some sort of e like this. Okay. So complex exponential representation is used to actually analyze a signal. Okay, in general, okay, we have Vt equals to A naught cos omega t plus theta 0. So bear in mind, this is capital, capital A naught t. Okay, means it's not AN, it's not BN, it's not the small capital, small letters. Okay. Next, using Euler's theorem. Okay, so Euler's theorem says that Ej theta is actually cos theta plus J sin theta. So you see exponential representation, cos theta t, Ej theta t plus E negative j theta t over 2. You see, for this case, you have both negative, okay? You have both negative here, and this one is negative, this one is positive. Over 2, and the difference is you have with cos and sin, for the below part, I think denominator, you have 2j, okay? You have 2j, this one is only 2. This Euler theorem, I suggest you guys to actually memorize, okay? Maybe it's given in the question, but it will be useful if you memorize, okay? Because it will help you to solve faster, because it will be used frequently, this Euler theorem, okay? So I suggest you memorize it. Not that much difficult to memorize, I think, okay? So you see here, this is Vt A naught cos omega t plus theta naught, this earlier, okay? Which is in the time domain polar form. If we want to convert, okay, we need to consider this equation now. Okay, so we have Ej omega naught t. So now we replace this, the whole other than the j, with 2t omega, 2t omega t plus omega. And the same goes with this. We need to replace this with omega t plus 0. Omega t plus theta naught, okay? Over 2. So it is here over 2. You can see here, right? Over 2. So this is the complex exponential form. Okay. Wait, Okay, so where were we? Okay, so here is the complex exponential form. Okay, now we can you see in the graph difference. Okay, in the graph difference we have a time domain polar representation, and you see, and then we have in exponential representation. Okay, we have two. We can see the difference. Okay, so this is the time domain polar representation. We have real and imaginary. So this is for a naught cos omega t plus theta naught. Okay, so anti-clockwise. And exponential representation, you can see what is the difference. You can see the magnitude now divide by half, divide by 2. Okay, okay, your magnitude now is half, and then you have omega t plus theta and negative, negative omega t plus theta. So you have this one. You have, instead of having one graph here, you have two graphs here. Okay, for the exponential representation. Next. Next, the signal can be seen as one function. Okay, here exponential form double-sided spectrum. You can see here the word double-sided. So later on you will see this a bit different with the words double-sided. Okay, the signal can be seen as one function which is generated by two complex components. Okay, this signal can be plotted in amplitude and phase spectrum as below. Okay. So the signal can be seen as one function generated by two complex components. So you have an amplitude versus frequency. Then you have also here phase versus frequency. So observe this equation which we have been solved from previous slide. So you see amplitude and frequency. You have V naught over 2 because this is the amplitude at omega, and the next one is negative omega. So here. And you have V naught over 2 as the magnitude divided by 2. So this one is continuous. This one is continuous. This arrow is should start from here. Okay, there is error when I'm doing the slide. So it should be continuous just like this. Okay, continuous from here. Okay, I will change this later on. Okay, in case if you later on lecture in advance, if you have the slide before, so you need to correct it yourself, because I say by having the slide before, your slide will not be updated. Okay, logic, because you have slide before class. Where were we? And then the phase. Okay, the phase you will have this one is theta and theta positive, so you will have positive, and then negative theta you will have negative. Okay, you have negative theta. Okay. Now the next is example. We have a frequency domain signal versus exponential form. Okay, frequency domain signal versus exponential form. Single-sided spectrum versus double-sided spectrum. Okay, sorry, I think I forget to inform. I'm not sure if any of the student in section 4 have problem with the test 1 and test 2. I think no. If there is student have problem with the test, which is not due to clash, which is not due to test clash, you will have a test. Okay, there will be no test replacement. Okay, I forget to explain. There will be no test replacement. If you cannot attend test 1, your test 2 will be 20%, something like that. If you cannot attend test 1, your test 2 will be 20%. So it will be more risk there, because your test 2 will be 20% instead of 10%. This is because you cannot attend test 1. Okay, there is no test replacement. I decided to be that way. Okay, because once each section have problems with tests, the whole lecturer will not be drafting the test again. It's only the lecturer with the section that have issue with the test. Means it's me. However, this is depend on the lecturer whether the two option, if I'm not mistaken, whether it's test replacement or increase the weightage of the next stage for the student having this clash issue. Okay, but so far section 4 have no issue. Okay, good for that. So you just sit the test accordingly. Okay, so here frequency domain signal versus exponential form. Okay, so you can see it is single-sided here, only single-sided versus double-sided. You can see, right, double-sided, because now we have negative. Okay, we have add the negative value, okay, negative sides. So this is double-sided, okay, pretty self-explanatory. So this A cos omega t plus 0 plus theta, so this is your amplitude spectrum and your phase spectrum, okay. And then this is the double-sided. So double-sided, you have at omega t and negative omega like this. Then you have the amplitude divided by 2, which is half of the time polar form, okay. Then the phase is you have negative, positive, and you have negative at omega, okay, omega and negative omega, okay. This one, if you open, you will have negative. If you open, so you have negative theta, okay. So next is the given signal, okay, of gt plus 3.4 cos 10t plus 1.2 cos 10t plus sine 20t plus 40 plus 5 cos 20t plus 40 degree. Okay, I will demonstrate the answer later, how to solve it. Okay, now first question A, you want to represent the serial in form of the trigonometric Fourier series and then sketch the single-sided frequency, means it's only single-sided. Second, represent the signal in the form of complex exponential Fourier series and then sketch the frequency spectrum. Okay, what do you think? Is it double-sided or single-sided spectrum for 1B? Can you guys answer? 1B, is it single-sided or is it double-sided spectrum? In the Google chat. Okay, good. Means you guys can see. So the question can be tricky. You see, 1B, 1A suddenly they mentioned single-sided, but 1B they didn't mention whether it's single-sided or double-sided. So you need to know where to look the other answer for that. So they already give answer indirectly. They say exponent. So that's why it is double-sided. So, but you need to see, if you don't really aware what is exponent, what is the characteristic, then you don't know whether it's double-sided or single-sided. Okay, and then sketch the frequency spectrum. Okay, exit full screen. I'm changing screen to my touch screen. Wait for a while. If you guys have question at this time, I mean during my demonstration of answers, please let me know using Google audio. Don't chat because I cannot, because my eyes looking at the slide and also looking at the and trying to do the answer. I mean solve the question. Okay, so I cannot look at if you have Google Chat or WhatsApp. Okay, so let's see. We try to write the question first. Okay, question 1A, but before that we just write first GT equals to 4 plus 3.4 cos 10t, okay, plus 1.2 cos 10t, bracket, put bracket. And then the next is you have sine 20t plus 40, okay, and then you have 5 cos 20t plus 40 degree. Okay, this one. So now try to simplify this first. Okay, we try to simplify this first before we, okay, slowly. Okay, you see, 4, nothing to be solved is still 4. How about here? Cos 10t and cos 10t, you can see they are identical. Okay, they are identical for this part. They are identical. So we can just add it together. So 3.4 plus 1.2 is what? Someone can answer to me using Google Audio. 3.4 plus 1.2 is what?
4.6 looks.
4.6, huh? So it is 4.6. Okay. Then the next is we try to settle this. If you can see this guy, this 20t and 20t plus 40, they are the same. However, one is in sine and one is in cos. Okay. One is in sine and one is in cos. I think I left some thing here. Okay, I left something. Okay, 1.2. Okay, there is 1.2. Sine. Okay, so correct. I don't leave anything. Okay. Then what we can do is that we need to convert. Okay, we need to convert them. Okay, this sine and cos, we need to convert them to one form, which is for the cos. Okay, so now an. Okay, you have an. Maybe you can have different colors. An equals to square of an square plus bn square. Okay, which is here. Okay, will be your 5. Okay, an is your 5 and bn is your 1. So what is the answer here? Can somebody help me? What is the answer here? And then you have 10 theta. Anyone can answer here? This one. What is the answer? Value. Okay. And then here is tangent, inverse tangent. Okay, inverse tangent. Negative. Don't forget negative here. Okay. And then you have bn over an. Okay. So you have inverse tangent 5/1. Okay. So can you guys help me? What is the theta and what is the an? What is the an?
5.099.
5.1. 5.1. Okay. How about theta?
Negative 78.7.
78. Wait. It should be 11.3.
If 11.3 is inverse tangent negative 1/5.
Oh, negative 1/5. Sorry, it's 1/5. 1/5. Okay, 11.3. Okay. So your bn is actually 1. Okay, your bn is actually 1. Your an is actually 5. Okay, so where's the things? Okay, never mind. I don't know where's the slide before. I lost already the slide. Okay, so 11.3. Don't forget to put degree. Don't forget to use degree here. Okay, don't forget to put your degree there, because it's important, even though it looks like a small circle there. So now you have this, then you write in the combined form. Okay, combined form, which is an. Now you have capital N. Okay, maybe I use different color to. Okay, now you have an here. An. Okay, now capital A, and then cos. And then 20t. Okay, you see here 20t. Okay, and then you have 40. Don't forget you have 40 there. 40 degree. And then you minus with 11.3. Okay. So an is what? An is 5.1 cos 20t. Okay, and then what is it? I think this is 28.7. Okay, plus 28.7. Okay, something like this. Okay, then only then you put here. Okay, you put here. So it is 5.1 5.1 cos 20t plus 28.7 degree. Okay, something like that. Then you need to produce. This is not enough, because question now say first they say represent the signal in trigonometric Fourier series. Now you have it, but then you need to sketch now the single-sided frequency spectrum. Now you need to sketch. Okay, you need to sketch. So you have two graphs. Okay, one is the amplitude, one is the phase. Okay, so let's see the amplitude first. The amplitude 4. Okay, you don't have any angular frequency there. Okay, it should be start here. So we can use different answer. Okay, we can use, okay, let me use different graph. So here is your 4. Okay, 4. Okay, and this for phasor they are 0, so it's here. Okay, the next is 10. Omega is equals to 10. Omega equals to 10, so you have 10 here. You have 10 here. For amplitude, it is what? Amplitude is 4.6. Okay, 4.6. So a bit up there, 4.6. And then how about the angle? There is no phase shift, so it's still 0. Okay, you can use X, whatever. Okay, and then the next, you have this 5.1 cos 20t. Now your omega is 20t. So 20, this is 20. Okay, then you have 5.1, a bit higher. Then you have this 28.7. Okay, 28.7, your phase shift. Okay, so this is your theta. Okay, this is your theta. So this is your amplitude. Okay, this is your amplitude. So your equation is 4.6 cos. Okay, so this is it. Okay, how you sketch it. So it's like single-sided. So let me screenshot. Okay, this is what I told you. You guys, if you have lecture slide before my lecture, you will not have the answer. Okay, you will not have the answer because I demonstrate the answer inside the class. So you may have the lecture slide before, but you don't have the answer. But thankfully that you guys can refer to the recorded lecture later on. Okay, live lecture, because if you have the slide before the lecture, your slide is not updated. It's logic. It's just logic. Okay, so because like this, you can see I actually put inside here for the students that that have the lecture slide after. You can see this is this from other lecture. This is section 3. Okay, which before you guys just now, and this is our section. Okay, so you don't have this kind of slide if I share the lecture slide before. Okay, next is what is the question?
Sorry to interrupt, total is 11:50 now.
Oh, okay. Okay, we will erase at 11:55. Thank you. Okay. So now let just 5 minutes. Okay, now this one is represent the signal in the form of complex exponential series. Okay, I think I already waste my 5 minutes later on just to write again the question. Panjangnya. Okay. I think I will use the time just to write again GT. What's like this? Okay, GT. Okay, GT. 4 plus. Maybe we don't. Okay, I don't start from the beginning. Okay, just 4 plus 4.6. Okay, we just use the same just now. Simplify it. Okay, 4 plus 4.6 cos 10t. Okay, in bracket plus 5.1 cos 20t plus 28.7. 7. Okay. Now we need to sketch into uh, our amplitude and phase spectrum. Okay, but before that we need to convert. Okay, we need convert to complex exponential form. Okay, so later on, okay, this 4 nothing we can do is still 4 here, but this one you be implement the Euler's theorem. Okay, you will implement the Euler's theorem, just put in bracket like this, and then you have 5.1 cos, and then you have another Euler theorem here. Okay, Euler theorem is just now where you have wait Euler theorem where you have e j theta is equals to cos theta plus g sine theta, something like that, and then cos theta t equals to e j theta t plus e negative j theta t over 2. Okay, then how about sine? You have sine theta t exponent j theta t. We don't have to use sign here because question we already combined, you see. And then minus e negative, negative j theta t. Okay, you see here it is negative, and then different we have 2 j. Okay, okay, never mind. You guys rest. We will continue at 12. Don't leave the session. You guys can rest. 11 until 12. Okay, you guys can rest or go to toilet, whatever. Okay. I mentioned to you guys, if you have question, ask in the Google chat. Okay, I think mention, right? Ask in Google, just interrupt me. Okay, this student, I don't know, even though you repeat, you say, please, please cooperate. Okay, you guys ask me in WhatsApp. Okay, at the same time, I'm lecturing. I'm my eyes looking at the slide, and I also looking at the painting. Okay, please be understanding. One student even asked in WhatsApp. I don't know why. I already mentioned. Please understand. I cannot. I only have two eyes. I cannot look at four things. And look at WhatsApp, look at Google Chat, look at slide, look at. It's not possible. Okay, I don't want to respond to that student. Okay, he asked me in WhatsApp. I already said please ask during the lecture. Okay. Continue. One student, even though he don't really respect what I'm saying, okay, because I know how can I'm doing look at so many things. I only have two eyes. Okay. So what is the his question just now? Okay, what is his question? Where is the lecture slide? Okay. His question. His question. Oh, his question. This one. Okay, his question is this one. Why 3.4 and 1.2 is not squared? Okay, logically it is not squared because this one is the same. It's just that the multiplier is different to 3.4 and 1.2. Okay, so we just need it up. Actually, it is just like mathematics where you have 3.4a. Okay, mathematics 3.a plus 1.2a. So what is the answer? Because this one is the same A. So it should be 3.4 plus 1.2 should be only 4.6. So no need to square it. So if you notice this, these are all the same also. Cos 20, cos 20, they are the same. The only difference is the multipliers, the coefficient. Okay, the 3.4 and 1.2. So no need to square. Understand or not? Understand? I know. Okay, I hope the student understand. Okay. Imagine, because of one student, I delay a few minutes just to respond to him. So can you imagine? I hope student can understand my limitation. I cannot respond at WhatsApp and at the same time I'm given lecture. It's not possible. please be understanding. Later on, if you are in my place, maybe you will understand. I cannot look so many things at one. Okay, so you see, now using Euler's theorem, now you have cos 10t, you need to convert to exponents. Okay, I use different colors so that you can see it is, you can distinguish it easily if you use different colors. So here, okay, so you use exponent, okay, e, then j, okay, you use this one, 10t, okay, and then plus e negative j 10t, okay, and then don't forget divide by 2. Okay, next you have 20t with the phase shift here, 28.7. So similarly, e j, however, it's a bit bigger now. Instead, now you have 20t plus 28.7. Okay, then you plus with, okay, sorry, because I don't have enough space, e, now you have negative, okay, you have negative j 20t, okay, plus plus 28.7, okay, something like that, and then close bracket, and don't forget divide by, don't forget this divide by 2. Okay, now simplify further, this is still 4. Now however here you have 4.6 divided by 2, right? So it is 2.3. Open your bracket, you will have, okay, okay, open bracket. Now you have another one, 2.3. Then with E, negative, negative, J 10t. Okay, the next one is here, you have here, you have 5.1. 5.1 divided by 2, you have 2.55. Okay, then you have E. Okay, sorry, this one is no more cost, no more cost, because we already converted. Okay, no more cost. Okay, 2.5 E, then you have E J 20t plus 28.7, okay, something like that. Then you have plus 2.55 E negative, don't forget negative J 20t plus 28.7, okay, something like that. Now we need to draw our graph. Okay, this is amplitude. So this is our phase, okay, phase spectrum, okay, phase. So remember, this is omega, this is omega. So this is the basic, okay. Even if you don't know the answer later on, let's say you answer wrongly, whatever, at least your axis is correct, okay. Then we try to solve, okay. Now for amplitude, okay, at zero angle, at zero angular frequency, it is 4, okay, and it is here for 0. Okay, the next you have 2.3 at 10, you have 10, so you have 10 here, then you have negative 10. Similarly, you have 10, you have negative 10. Okay, for 10 you have 2.3, okay, a bit smaller, okay, 2.3, and also you have 2.3 at the negative side. Okay, the next you have 2.55 at 28, sorry, 2.5 at 20t. Okay, you see this is 20, so you have 20. Okay, so I forget this one, we also didn't have any phase shift, so it's 0 here. Okay. Now the next is for 20. For this one is 22.55. So you have a bit higher here is 2.55. Similarly here you have 2.55 as well, a bit higher. Okay. So things are interesting with this because now we have phase shift. So here you have you have 28.7. Okay. And the other one you have negative. Huh? Because this one is positive, this one is negative. So next you have negative 28.7. Okay. So I take the snapshot of this. Put inside the slide, but since that, but now you have the advantage, you have the advantage of my slide after. But later on I will share before, so you won't have the all the answers like this. You don't have anymore. You just have the standard slide. Okay. So put my answer here. Okay. Now we go for the what is this? Okay. Example 2 for the continuous time periodic signal. Xt 2 plus cos 2 pi over 3t plus 4 sine 5 pi over 3t. Okay. You can see now the this one we have sine. First we have sine, so you need to make it 1. Depends on you. Okay. Now you have then you have a different angle. Okay. So try to sketch to do this at your own. Okay. Try to sketch this at your own, and actually there is answer here. Okay. Okay. So there is answer here. You can try. Okay. X to t is it the same? Yes, is it the same? Okay. So you guys be honest with yourself. Try this first. Okay. Try this A and B, and you check your own answer. Okay. Then we go to the next one is the Fourier series periodic signal. Okay. Fourier series periodic signal. What does it mean by periodic? It is repeated. Okay. So repeat itself at equal interval of time t naught. So t naught is actually complete cycle. So every complete cycle it will repeat, it will repeat, it will repeat. So this is periodic. Okay. So you see Vt is equals to Vt plus minus nt naught. Okay. Nt means that how many complete cycle is it? Okay. Where t naught is actually 1 over f naught. Okay. Complete period is actually 1 over f frequency, and n is your integer. It can be t plus 2t, t plus 3t, but it's always repeated. Okay, you will have the same pattern. So it can be sine signal, square shape, triangle, or sawtooth. Okay. So spectrum. Okay, spectrum is actually representation of periodic signal in the frequency domain by its frequency component. Okay, you listen this. You can, I hope you can distinguish representation of periodic signal in frequency domain by its frequency components. Okay, so this is what does it mean by spectrum. Okay. So here is Fourier series representation. Okay, Fourier series can be represented in two forms, whether it's trigonometric. Okay, what does it mean by trigonometric? With the cos and sine. Okay, with cos and sine, and complex representation, of course, with the exponential just now. So okay, where were we? Okay, then Fourier series. Fourier series, complex exponential Fourier series form. Okay, what is Fourier series? Okay, representation of complicated periodic signal in the frequency domain by its frequency component. Complicated, complicated, because if we to represent our signal in a periodic signal, it will be complicated. Okay, so that's why we are using Fourier series to actually to represent or to solve our answer. Okay, so that's why we are using frequency spectrum. We're using Fourier series instead of our normal periodic signals. Okay, so the presentation of musical sound as sum of wave of various frequency is an audible example. Okay, for example, you sounds whatever, you can have various frequencies. Okay, when someone's speaking, okay, someone speaking is actually have a lot of frequency. Okay, have a lot of musical sum as sum of wave of various frequency. Okay, so sometimes when you speak, it can become like 20 hertz, 30 hertz, something like that. Okay. Trigonometric frequency Fourier series. So the word trigonometry. So you can see trigonometry means we involve cos and sine. Okay. Periodic signal can be written as an infinite cos and sine function. So general form of Fourier series. Okay. General form of Fourier series. We have Vt A naught over 2 n1 to infinity. So please bear in mind, please take note or alert. You see here is n1 equals to infinity. Later on, you will see why I'm saying this. Okay, you see there's a different. Sometimes you can have negative infinity here. Okay, so please bear in mind the difference. Okay, n cos n omega naught t plus bn sine omega naught t. So you see, you have n here. Okay. So if you have n1, then you will have cos omega naught t. If you have n2, you have cos 2 omega naught t. So its expanded form is like this. Okay. So if you have n1, you have a1 cos omega naught t and b1 sine omega naught t. So this counterpart. Okay. If n2, you have 2 omega naught t and you have 2 omega naught t. But this one A2 for cos, this one B2 for sine. So A naught over 2 is actually DC current. Okay, DC current is actually the amplitude which does not change. Okay, it's DC. Okay, does not change according to it's always the same. Like if it say is 1, it's always 1. Okay, so AN over BN is Fourier coefficient. Omega naught is fundamental frequency, and omega naught is harmonics. Okay, when we refer to harmonic, means it is repeatable. Okay, it is repeatable. Signal. Okay, n can be 1, 2, 3, 4. So the question will be, let's say question ask you, it will not be cruel. Ask you to solve until infinity. No. Let's say they will mention until 4th harmonic, until 5th harmonic. Okay, so you will see whether you need to solve n until 4, n until 5, or n to 6, something like that. Okay. Trigonometric Fourier series to plot frequency spectrum Fs should be represented by this. Okay, Vt plus infinity summation of 1 from 1. Okay, if you see this is started from 1. Okay, started from 1, not started from negativity. So it is a single-sided. Okay, it's a single-sided spectrum. You can see it is start from 1. And then you can see the angle. Okay, the angle for Fourier series is theta n. Inverse tangent negative bn over an is a bit similar to the previous slide. Okay, and an, the capital N, an is an square plus bn square. Okay, so to have Fourier coefficient an plus bn, we can obtain it by integration. Okay, you can see we can obtain it by integration. However, lucky you, the younger generation, so the syllabus made a bit more easier. You don't have to solve this integration. Okay, if I know mistaken, you just need to use the table. Okay, you just need to use the table that will given to you. Okay, so during my time, if I'm not mistaken, we integrate this, if I'm not mistaken. So a bit more difficult challenges, but never mind. The good thing is that we learn more. Okay, even last time to get A is 85, only A. 80 to 84 is B. We don't have A plus A minus last time. So you can see last time it's even more difficult to get A from UTM. So if you get some CGPA, maybe now 4, but later if adjust to UTM last time, maybe it's only 3.67, something like that. Because we 85 only getting A, okay, for previous batch. Okay, I am the older generation. Okay, where we have more strict. Okay, so Fourier series symmetrical properties. Fourier series symmetrical properties. So we can use these symmetrical properties to simplify our equation. Okay, so you don't have to do so many things. Okay, because this some things they already simplify. Okay, for example, A naught. Okay, A. Be careful. A naught small letter is merely the time average. It is 0 if it is symmetry in the period of time. So if you have signal which is symmetry along the horizontal axis, A naught is automatically 0. Okay. Second, Vn equals to 0 if the signal we have is a cosine-like even symmetry. Okay, I think you guys know, right? Cosine symmetry, cosine signal. So if you have cosine symmetry like this, okay, cosine symmetry. So your Bn, okay, so your Bn should be 0 if you have this symmetry, okay. Okay, the next is if you have a sine-like odd symmetry. Okay, odd symmetry is what? Is it symmetrical or anti-symmetrical? Odd symmetry. Okay, what is it? You guys can answer. What is sine is what? Anti-symmetric or symmetrical? This is sine wave. Okay, thank you for answer. It is anti. Why? Because you see, if this is positive, okay, if this is positive, this is negative. Okay, so it's anti-symmetrical. So this one for sine-like, for just now, for sine-like, okay, sinus-like odd symmetry. So if this condition, then your an should be 0. Okay, you see, different case, it will result in 0 for certain coefficient. Okay, so this one is for cos and even symmetry, Bn will be 0, and then an equals to 0 for if you have sine-like signal, okay, which is the anti-symmetry. Okay. Okay, and then an equals to Bn 0 for all value of n if Vt has a skew rotational symmetry. Okay, skew, I think you already have skew graph in the previous lecture. You can refer to the slide before. What is the skew? Okay, and for skew case, an Bn is 0. Okay, for all value of given value. You can see how a skew graph will look like in the previous slides. Okay. 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 Now, Fourier series symmetrical properties. This is example. Now, this is the trigonometry. Okay, trigonometry. Why we mention is trigonometry because we have cos and sine here. Okay. So A naught over 2. This is your DC, and then you have summation sigma. Okay, 1 until this one and this one. If signal Vt is an even symmetry in the period of time t, the equation for Fourier coefficient can be simplified and become, okay, this one you mentioned, even symmetry. So if even symmetry, what is 0? Bn is 0. Can see? Bn is 0. And because it is symmetry, your A naught should be 0 as well. So 0 divided by 2 is 0. So then you settle what you need to settle. You only need to settle An. Okay, you need to settle An because your Bn and A naught is 0. This is not politic, not Bn Barisan Nasional, it's Bn coefficient. So this one 0, this one is 0. So you only need to settle for An and using table. Okay. Next,
If signal is an odd symmetry means it's like a sign. Okay, if it's odd symmetry, what is 0 now? Is an is 0 from n 1 2 3 and so on. And because it is symmetry, regardless of even or odd symmetry, n naught will be 0. So 0 over 2. Okay, 0. Okay, and then because this is 0, this is 0, then you need to solve by only the bn part. Okay, this you need to settle using table lah. No need to integrate lah. Don't worry. Okay. The question here, okay, find the trigonometric Fourier series for VT until fifth harmonics. Okay, you can try this at home. You can try find the trigonometric Fourier series for VT until 5 harmonics. So n until what now? N until what? 0, 1, 2, 3, 4, 5, what? 6, 7, 8, what? N is what? N is what? 4 harmonics. So you need to know first what is your value of n. Okay. And then trigonometric Fourier series. So you need to mention, you need to use this, okay? And n1 until here is until what? If it's 5 harmonic, this one is what? Above here is what? Can someone answer me? Chintong answer. And the other, how about the others? What is the n if the until 5 harmonic? Only Chintong answer. The other what? What is your guess? Okay, it is 5, huh? It is 5 because it's a fifth harmonics, huh? If we refer to previous slide, where is the previous slide? Okay, here, harmonic frequency. Okay, so n 1 2 3 4, so it's 5. Okay, 5 harmonic frequency, so it will be 5. Okay, it will be 5. So we have until 1 until 5. Okay, you guys can try to settle. Okay, try to settle this one using this one. Refer to this one, and you see it is sign like. It's odd symmetry. If it's odd symmetry, what is 0? Is it b n is 0 or n is 0? Okay, and because it is symmetry, n naught will be 0. Okay, but which one is 0 for odd signal? Okay, odd signal which is anti-symmetry. Okay, you guys can try this at home. Okay, this is the amplitude, 20 millivolt. This is your amplitude, or we can say your DC, okay, is 20 millivolt. Okay, and then complex exponential Fourier series. Okay, using Euler relation, we can express Fourier series in complex exponential forms. So cos n omega naught t, e j n omega naught t, and so on. Okay, you have sign. So complex Fourier series, okay, complex Fourier series, you can have, this is the trigonometrics, okay, then you use Euler relation, Euler theorem, okay, you put it inside just accordingly, okay, you just insert accordingly, e j n omega naught t here, and plus negative e j naught omega naught t over 2. And because this is sign, you will have 2j and e j n omega naught t minus, okay, minus e negative j n omega naught t. So then you so further, then this n naught over 2 you can label as c naught. Okay, so question, let's say question give you c naught, you should know c naught is what? C naught is actually n naught over 2. Okay, c naught is not equals to n naught. Okay, so remember the differences. Then rearranging this formula on factorize e j n omega naught t, you will get an minus jbn. Okay, because you factorize this guy, okay, over 2. And then the next is e j n minus j n omega naught t, which this one, we factorize it, then we have an plus jbn over 2. So this is your cn, okay, cn, and this one is your counterpart, which is c negative n, okay. So you will have a c naught, cn plus c minus n, okay, here. Then, if you simplify further, the trigonometric, from the trigonometric here, from this one, okay, if you simplify, it will become this one, Vt C naught. Now start from 1, start from 1 because we all consider negative case here. Okay, until infinity Cn e Jn omega naught t plus C minus N e negative Jn omega naught t, where Cn is a complex conjugate of C negative N. During your secondary schools, if I know, you guys, I think you guys did learn about complex conjugate. Complex conjugate is like the magnitude is the same, but the sign is not the same. Okay, if one is positive, one is negative. If one is plus 3, one is the negative 3. Okay, something like that. Okay. So where Cn is complex conjugate of C minus N. Hence, complex Fourier series can be represented by Vt equals to infinity over negative infinity. Now you can see we try to combine this to make it even simpler. Okay. So that's why we have negative infinity and infinity. Now we consider to put this negative side in here. Okay. You can see, right? Now we have negative infinity. That's why in the earlier slide, in the lecture, I say you need to see the difference. N1 and negativity, they are differences. Okay. So now this is difference because we simplify it further. Okay, where the complex conjugate we consider just inside here, the range. So from negative infinity until infinity, then we have the more generalized term, which is Ejn omega naught t, however, with the range from n negative infinity. So where Cn is actually 1 over t, integration of 0 until complete period of t, Vt Ejn omega naught t, and with integrate with respect to t. Okay. So this is the equation that is given. The equation that is given to you. Equation given to you. Sorry, I'm sleepy. Okay. This is your trigonometric form. You have cos, sine. This is combined trigonometric. Combined means you combine both of these to have cos. Okay. Then you have exponential. Obviously, the exponent term. Okay. So for this one is you, if I'm not mistaken, and actually yes, you have this in as your final exam. Okay. So you see, you don't need to to integrate whatsoever. Fourier coefficient A naught, 2 over t, t over naught, ft, and so on for an and bn. And you know just now when we learn for symmetrical signal, a naught over 2 is average value. Okay. An is actually 0 for ft, which is odd. Okay. I think this is just now odd symmetry or even symmetry. And then bn is 0 for ft even. Okay. So an bn equals 0 for n even. Therefore, ft is a skew function which consists only odd harmonics. Okay. How to skew graph, you can refer to the previous slide. Okay. There is how this slide showing how the skew look like. Okay. Skew function or skew signal. Okay. Then combined trigonometric. Okay, you have combined trigonometric form. You have ft equals to a naught plus summation. Okay, summation. Start from 1. You can see here. Start from 1. Be careful. I keep on reminding because this can make a difference. That n1 and until infinity an cos nt plus something hilang. Combined trigonometric, I think theta n hilang. I think theta n lost there. Okay, this is actually the combination. You can thing is theta n here. Okay, hilang pula sini. And a naught over a0 over 2. And you have an, this one is a naught, this one is n, different. An is actually a n square plus b n square root. Okay. And then you have theta n, which is theta n is inverse tangent of negative bn over an. So it's theta n. Theta n is the one disappearing. Then you have a0, a capital 0 is a0 average value. And you have an equals 0 for n even if ft is a skew function. Okay. Is a skew function. Then you have the exponential form. This one is how we derive until this just now. Okay. So exponent, this one is we simplify. Okay, how to get this? You can refer to the previous slide just before. Okay, then you have Cn, which is 1 over t. T over 2, what negative t over 2. Why we consider negative t over 2 now? Why we consider negative now? Because we consider the negative here as well. Okay, just now. Okay, we consider the negative, which is the complex conjugate was Cn and C minus n. Okay, so that's why here when integrate we have negative and positive instead, because here is negative and positive. Okay, so C0 for average value, Cn real for Vt if Vt is even. If your signal is even signal, okay, your Cn will be real. Okay, next, if your signal is odd, which is anti-symmetry, your Cn will be imaginary. What does it mean with imaginary? You will have Jn, okay? You have J, which is not real, okay? And then Cn equals to 0. Cn equals 0 for n even if, okay? For n even if ft is a skew function, okay? First, Cn is 0 for n that is even. Only if your ft is a skew function. How you do that? It will be like skew function, only then you can implement it. Okay. Okay, with that we finish earlier the class a bit early. I will share the slide later on in the lecture note, and then look at our this is section 3. This is section 3. Now I want section 4. Okay, I want section 4. Now you have time, like 5 minutes. Okay, you can write what have you learned today, because we have lecture around 1 hour plus 1 hour plus. Maybe okay, you can write what you have learned today. Okay, before you leave the class. Okay, where is it? This one. Okay, what have you learned today? Just random thought. Okay, just random. You don't have to write properly. Okay, maybe you can say I learned about complex exponential. I learned about spectrum to represent periodic signal. I learned about Fourier series to represent complex periodic signal. Okay, so go to your e-learning. Just provide. You don't have to waste time so much. Just 1 to 2 minutes. Okay, so you can do it now. Anything. Okay, it's just to show me what is the most significant that you learned today. Okay, don't worry. It's don't have mark. It's just that I want to learn, to know what students have been learning during my lecture. Okay, so you guys can go to your e-learning now. And after you guys put, then you guys can never mind, you guys do first 12:36 until 12:40. Okay, go to your e-learning, and what have you learned for today? Is this the correct section? Yes.
Okay, go to your e-learning. I didn't see a response yet. Okay, don't worry. No right, no answer. No right, no wrong. I just want to know what you have learned. Okay, what things that you remember during 1 hour lecture. Later on, I will have teaching observation. There will be panel observing me teaching. So I'm not sure how is it go, because my section is already have more students. Maybe I will take maybe some students combined with section 3 to be just like a teaching observation. Okay, maybe 10 from section 3, 10 for section 4. I'm not sure. Okay, but I will invite you guys. Okay, for teaching observation, someone will observe me how to teach. So that time it will be a bit more schematic, a bit more not the schematic, what to say. I will be more